All right, so for the next example then, we are looking for a resultant, which comes from taking u, subtracting v, and adding w. So, following the method we had before. Got grid paper, so that's great. I'm going to take my u vector, place it over here, and I'll mark it as the u vector. Now, what does negative v mean? So we're subtracting the v vector. What does that mean? It means the direction changes. The direction is changed to the opposite. All right, so if you see a negative vector, it still has the same size. However, it's changed directions. So the v vector, if I bring it over here, okay, it should be pointing that way if it was adding, but subtracting, so it's got to point the other direction. So my v vector gets swung around, and it's now right there. So that's negative v plus the w vector. So I'll add that in. There's my w vector. So there we go. We've drawn the picture. Now I just need a resultant vector. Now I'm going to go to go a little bit more technical here. So there's my resultant vector. Okay, that's it. Now I'm going to find magnitude and direction of the resultant because that's what I'm looking for here. Okay, so I need to know a direction and I need to know a magnitude. How can I find magnitude and direction for this vector? Hopefully some of you are sitting there saying, hey, I know how. We can create a triangle. So what we can form is a right triangle because we have a grid. So we might as well use the grid. There's my right angle, 1 unit there, 3 units there, and I want this angle right here. Okay? So how do we find magnitude of the resultant? So this is going to be off to the side. I'll make this note. So some of the notation, and I didn't talk about this one earlier. If you have the horizontal bars, that is magnitude of a vector. Magnitude of a vector. Okay, that's the horizontal bars. Okay, so how do we find the magnitude of the resultant? In this case, from Pythagorean theorem, I'm going to give us a formula because what the nice thing about this is, it would be the magnitude of r squared is equal to magnitude of the x component squared. So maybe I'll even go simpler than that. Let's just go back straight to a squared plus b squared equals c squared. Well, the magnitude of the resultant is your c, it's your hypotenuse. Magnitude of the x component squared plus magnitude of the y component squared. So at the end of the day, this is the formula that we want. Magnitude of resultant is the square root of our x component squared plus the y component squared. So there is a formula you want placed on your cheat sheet. So over here, let's finish this up. So the magnitude would be 3 squared plus 1 squared. So it would be the square root of 10. And it's units. We don't need to have the calculator out. How do we find that angle theta? How do we find the angle theta? Well, we know that the resultant is the hypotenuse. I know the 1 is the opposite, and the 3 is the adjacent. We always will have the triangle drawn, so we always will know O and A. If we always know O and A, that means we are using tan theta. All right, so that means that the angle of our vector is always going to be the tan inverse of O, which will be, you know what, I'm just going to leave it as O over A at this point in time. All right, to avoid any confusion. All right, so in that case then, for our triangle here, theta equals tan inverse of O over A, so tan inverse of 1/3. So calculating that up, so 1 divided by 3, inverse tan, and we get 18.4 degrees. 18.4 degrees. So therefore, our resultant is the square root of 10 units. So that's our magnitude. The direction would be, if you face south, you would have to rotate 18.4 degrees towards the east. to get facing in the direction of our resultant. So there we are. That is our final answer. So this looks a little bit more complex because it has the notes down the side here, but let's try one more and see how this goes. So now I have vectors that have been scalar multiplied, so they're larger. So if we go through here and go through and do the same process, I know my resultant is going to equal 2u plus 3v minus 4w. So that's what I'm looking for is the resultant. So I need 2u's. So I'm going to cheat a little bit because I know kind of the direction it's going to head. So I'm going to start more in the middle of the page over here. So there's 1u, there's 2u's. All right, and yeah, you can draw it as one line that goes 6 squares. There's nothing wrong with that. This is for note purposes. Plus 3v's. So 1, 2, and 3. And I think I'm going to have to change that. I want this to fit on the page for you, so I don't want to confuse you just because it won't fit on the page. So let's go with, let's reduce that 4w. You can scratch that out. Let's just make it a 2. Okay? I want it to stay on the page. When it goes off the page, it's a little bit frustrating. So we're just going to go with 2 v's. Now remember, it's a negative v. Or sorry, negative w. So the direction, normally it should have been here. We need to flip it around. So it's actually going in that direction. All right, so same thing. I need to flip it around first. Put it on. So there we end up. Okay, so we did switch it to 2 w's, and these are negative w's. So negative 2w. So there's our resultant. So our resultant is from there to there. Okay. That's the frustrating part with doing it geometrically, drawing it with pictures, because if you don't start in the right place, it goes off the page. It becomes very, very frustrating. So we'll talk about that in a future lesson. So magnitude of the resultant is x squared plus y squared. So you need to create a right angle triangle. So I'm going to create it this direction. You could have went the other direction. You got the correct answer, so you could have done the blue one. It did not matter here. The angle that I'm interested in is this one here. So theta, 1 unit and 1 unit. So that means that the magnitude of the resultant is 1 squared plus 1 squared, which is root 2 units. Okay. Using our formula from the other page, tan inverse of our opposite, which is 1 over 1. So that gives us 45 degrees. Don't need the calculator for this one. So therefore, our resultant is root 2 units. And the direction, the way I drew my triangle, I was facing east. I then rotated 45 degrees to the north. Okay, and that gives it the direction of that particular vector. So what happens if we don't have a grid? What happens if we don't have a scale? So I have vectors that simply look like this. Okay, so what are we given? I'm given a magnitude of a vector, and I'm told, okay, this goes off, let's say 20 degrees, this one's 10 degrees, but I have no grid. All right, well, enter the triangle law of vector addition. So, triangle law. First one, you draw vectors, head to tail. Oops, head to tail. And let's just stop it there. So I will end that statement there. So I take this vector, which is not cloned. So I'm going to just, and you can just roughly draw this because we're just giving ourselves a sketch. So there's vector u. I just want you to see what it's going to look like here. So clone that one. And vector v. So we do exactly what we did on the previous page. We just don't have a grid, so you don't have to worry about a ruler in terms of measuring the angles or anything like that. So that's stage 1. Stage 2 is draw the resultant. Draw the resultant. So our resultant is going to be right there. Step 3, and this is the tricky part, use grade 9 geometry. And that would be the F pattern, the X pattern, the Z pattern, etc. to determine angles. And I don't have any numbers at this point in time. I guess I could use the 20. So from the note above there, I know the U vector, and you gotta be careful here because this resultant is not horizontal, right? So I know this angle with the U vector is 20 degrees. I know that V vector made a 10 degree, okay? So I don't have any angles inside the triangle yet. So if I was to use a Z pattern, so that means if I extended that horizontal line up here, okay, then I would have a Z pattern right here because my green lines represent horizontals. Armpits smell the same, so that would mean this angle up here would be 20 degrees. So I would now know that this angle here is 180 minus 20 minus 10, which is 150 degrees. So that's kind of what you're going to be doing in step 3. Step 4, use cosine law. So there's the cosine law. Use cosine law to find magnitude of R. And the final step, step 5, use sine law to find direction. All right, those 5 steps are always the same. Okay, step 3 is going to be the hardest part. Once you have the angles, then you're all set to go. All right, but number 3 will be the hardest. So I'm going to leave it there. I've got 2 examples to finish up then with the adding and subtracting vectors, and then we'll continue on our way. So if you have any questions about this part of the note, please make sure you mark it and ask me in class the next day.